Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about a technique known as log-based recovery to provide the atomicity in an atomic transaction. How to implement that log-based recovery and how to actually the disadvantages affect the log-based recovery. One way to ensure atomicity of a data is to write all the records on a label storage that the notifications has been done to all the various data that are accessed by a transaction. One way of doing that is the write-ahead logging. In this type, the system maintains a data structure associated in a stable storage called log. Now the log record contains a transaction right and all the fields associated with it. The fields are, first is the transaction name. It is a unique name that is provided with the transaction right to identify that transaction in the system. Next is a data name. This is also a unique name to the data that it is needed to be identified. Third one is the old value. This is the not updated data that is associated with the values of the previously. Fourth one is the new value. This is the updated or modified value associated with the data. Now some special log record requires to inform about the start of the transaction and the end of the transaction that is being committed or aborted. Before a transaction starts, we need to find a record in the log that is written as TI start. It is written like this. Before the transaction starts execution, the TI start record should be written to the log. It should be written like this. Like this, the TI start record is written to the log. Now during execution, any write operation by TI is preceded by the writing a new and appropriate record to the log. After the write operation has been done, then the TI commits record should be written to the log like this. Because the information in the log is used for reconstructing the state of the data that has been modified by the transaction and accessed by various other transactions, so the actual update should not take place before writing the actual data of the value to some storage output. Now if the data is written to the stable storage, then only the actual modification that is made by the transaction to the data that it has accessed will be performed. We therefore be required to perform a write X operation written like this. To the log records corresponding to all the values of X that is made transformed by any transaction TI. Note there are many performance penalties inherent in this system. For every one logical write, there is associated with two physical writes. One is for the data phase itself and another is for the log record. So it needs more storage also, one for the data and another for the log record like the one. Now, if we need that it is an important and crucial data and faster recovery is necessary, then the cost is worth the functionality. Now, if suppose the TI is aborted, that unsuccessfully terminated due to some logical error or system error, then the data modified by it should be accessed and made to the previous value that was before starting the execution was recorded. So this recovery algorithm uses two phases. The first one is this undo TI function recovers all the data updated by the transaction TI to the old values before starting the execution of TI. And there is one more function known as This redo ti function updates all the values that has been modified by the ti to the actual new modified values. Now, if the system error happens, then the designer or the scheduler will choose among these two that the log discussion will be done. After discussing to the log record, it will decide that whether which transaction should be undone and which transaction should be redone. These undo and redo operations must be idempotent. That is, the multiple execution of this operation should result as of the single execution. This idempotency is to guarantee the atomicity is ensured and the data will be not lost from the non-volatile storage. Now, if abort is due to some logical error, then the data is simply done by the undo ti operation. This undo ti will set back the old values of the data. But if the system error happens, then the undo ti and redo ti will be decided by the log depending on these two instructions. Suppose that the ti has started with this ti start operation but it not ending with this ti commit operation. So, all the data should be performed undo ti, that is set back to the old value. And if the transaction contains in the log both the ti start and the ti commit operation log recommendation, then the redo ti operation should be done to set back the new modified values to the log. Now all the corresponding transaction data and their old values and new values can be found in this log. So this log-based recovery helps in atomicity providing of data consistency. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.